Welcome back. In the last session we have started with Poisson distribution, and I hope we all know what is the situation in which Poisson distribution is applicable. We have discussed about the theoretical concept, meaning and introduction with regard to Poisson distribution, and we have discussed the situation or case in which how a Poisson distribution can be applied. I hope you all guys have gone through it. We will discuss some of the adjustment case with regard to that. Let's come back to our case. Next case, it is known from the past experience that a certain plan there are on the average 4 industrial explosions per month. Find the probability that in a given year there will be less than 3 accidents. So let us study about this case with the help of a Poisson distribution, because in the initial analysis we can see that the events under the study are very rare and the number of occurrence of events is very less. That is one of the main logical steps or concept that can be used to identify whether the question that comes under the Poisson distribution situation. So before we go further, as I have mentioned earlier, for the computation part you will be needing the value of m, or it is known as mean of the Poisson distribution. So first of all, let us extract the data given in the question in a meaningful form, then you will get a clear glimpse with regard to that. In the question it is said that m equal to 4, and you may think that how the value 4 is considered as m. We have learned that m is considered to be the mean of the Poisson distribution, and how we are going to say that the value 4 that is mentioned in the question, where 4 industrial explosions per month can be considered as the mean of the situation. The mean can be represented by another term, average. So it doesn't mean that in the question they have to specifically mention the term mean of the certain incident as this one or that one, like that. If it is mentioning a term average or mean or likewise, depends upon the words that are synonymous to the word mean, you have to take that value as the mean of the Poisson distribution. For the time being, in the question it is mentioned that the average of that particular incident under the study is 4. We can say that m equal to 4. And here the n and p is given. Not given. So we can assume that the value of 4 is considered as the mean of the situation. If the n and p was specifically mentioned or it has been mentioned in the question, you can find the value of mean on the base of n into p. In that case, remember that. And make sure if there is n and m is specified and average value is specified in the question, remember, multiply that n and p value if you are getting the same average value or not. Usually it will be the same. Just remember that. And the equation for finding the Poisson distribution is p of x equal to e raised to minus m into m raised to x divided by x factorial. And here first of all let us write down the easiest part, value of m. So e raised to minus m can be written as e raised to minus 4 into m raised to x can be written as 4 raised to x. You can substitute the value of all the variables in the first instance. For avoiding the confusion only, I am using it as two different steps. And x factorial, let it be like that. And e raised to minus 4 is value 0.01832. Just go through the table that is given in the question and try to find out the value of e raised to minus 4. I hope you have gone through the previous mentioned case, that is the third semester situation where we have learned about the computation of e raised to minus m. Hope you all know how to find the e raised to minus 4, because you need to learn how to find the e raised to minus whatever the value to find the value of Poisson distribution. So let's come back. What was the case under the study? It is said that you are asked to find the probability there will be less than 3 accidents. So you are asked to find the probability of less than 3 accidents. So what is the meaning? Less than 3 accidents means what are the number of accidents that can happen? Less than 3 means 0, no accidents might have happened or can happen, or 1 accident can happen, or 2 accidents can happen. Since it is mentioned that what is the probability of less than 3, we are not including 3. That will be much better. So the situations are probability of x, the variable or what are the event under study, because we are asked to study the probability of number of accidents that is less than 3 value. It may be no accidents at all, or one accident may be in the situation, or two in the industry or factory, whatever it is. So it can be written as p of whatever the value less than 3. So it can be no accidents at all, so that is represented by x equal to 0. It may be one accident at a time, so x equal to 1, and it may be x equal to 2. I hope you understand the sentence meaning of less than 3 accident and how we have represented the same in this Poisson distribution pattern. So in the question you have to find the probability with regard to Poisson distribution on the values x equal to 0 or x equal to 1 or x equal to 2. So the equation is e raised to minus m into m raised to x divided by x factorial. You can either find the probabilities of x equal to 0 in this equation one time, or you can use the same again for p of x equal to 1 in another equation, and p of x equal to 2 another third equation likewise, and you just need to add all these, because here it is mentioned or. In case of or, you will be adding together. You can do like that, or here I am showing you another easy method or trick for easily identifying that. Remember, even if it is x equal to 0 or x equal to whatever it is, e raised to minus m will be constant. It won't change. And we are multiplying that with m raised to x by whatever the denominator. So let us bring that item as a common factor, e raised to minus 4. So in the equation, if you are removing this one, what are the remaining patterns? M raised to x divided by x factorial. So let us identify the values, because in this part will be different. M raised to x divided by x factorial will be different for each of these three cases. So let us bring those items within the brackets and bring this one as a common factor outside. So m raised to x divided by x factorial for 0. And m raised to x divided by x factorial for 1 plus m raised to x divided by x factorial for 2. This is how you have to do the computation. Now we will substitute the values which we have extracted from the question in this equation. Though it will be like this: e raised to minus 4, let it be like that. We know that e raised to minus 4 is 0.01832. If anyone want to substitute it, okay, fine, go for it. Next one, m raised to x. We know that m is 4. 4 raised to, first one, x is 0. So x is 0 divided by x factorial means x 0 is 0 factorial. So first part is over for 0. Plus, that plus is written here. M raised to x. M raised to x. M means 4. 4 raised to x. Here we are finding this one is for 1. So x is 1 divided by x, again the number 1 factorial. Second part is over, plus m raised to x divided by x factorial, 4 raised to 2 divided by 2 factorial. So we have found individually this part for 0, 1 and 2 within a common bracket, and in the outside we have bring this one as a common factor. Now just substitute all the values. 0.01832 I have just substituted now, plus I hope you know how to solve this one, because we have learned about this concept in the theory, combinations and permutations area. So I am not going to explain that step again. So by solving using combinations or permutations cases, you will get 1, this one 1. If you solve this one 4 and this one 8. Just add all these 3, and if you multiply it with 0.0183, you will get the value 0.2382. So in the question you are asked to find the probability that in a given year there will be less than 3 accidents. So the probability of occurrence of less than 3 accidents in the particular plant or whatever the concern it is, the probability is 0.2382. Or we can simply simplify it as 0.2 or 0.24, like that. So this is how you have to deal with a Poisson distribution situation. I hope you have understand the concept. You may find it confusing at the beginning, but you will cope up with it by trying out more and more cases and questions. You will get the clear picture. The thing is, you have to find the value of m and e raised to whatever the value of m. Try to learn that. So let us try another case. Same pattern, the presentation of the question might be different, so you need to understand the concept. So let us discuss another example. In a town, 10 accidents took place in a span of 100 days. Find the probability that there will be at least 3 accidents in a day. It is almost similar to the case which we have learned, but there is slight change in the terms used in the question. So I hope you know how to find whether the question relating to a Poisson distribution or not. On the basis of details given, you can understand that it is a case of Poisson distribution. So in a town, 10 accidents took place in a span of 100 days. So out of 100, 10 accidents will come. So find the probability that there will be at least 3 accidents in a day. You are asked to find the probability of at least 3 accidents. We will come to that part. But before we go into the computation part, you need to identify some important items like m and how we are going to find m. So in the question, m is not directly given, but it is mentioned that out of 100 days, 10 accidents occur. So from that you can easily find one thing, that is probability. So first of all, let us write down main items given. The average number of accidents that means in specific days, that is 10 by 100, which can be written as 0.1 or 0.1, and it can be considered as m equal to 0.1. So you have found the average number of accidents. You can either found the value of probability and number of items likewise, or you can directly find this probability as the average of the particular incident. Whatever the situations or details given in the question, depending upon it, you can use the method up to your discretion. So average number of accidents occur in specific days. Out of 100 days, 10 accidents take place. So 10 by 100 you will get 0.1. So let it be the m. Next one, we know that the Poisson distribution function is p of x equal to e raised to minus 1 into 0.1 raised to x divided by x factorial, because we already found the value of m. So just substituting that value first at the initial, e raised to minus some, instead of that minus 0.1 into m raised to x. M is 0.1 raised to x. We will come to that part. And finally x factorial. And in the question you are asked to find the probability that at least 3 accidents in a day. What is the probability that at least 3 accidents? So that means you need to study the situation where at least 3 accidents means accidents occur in that whatever the days or the situation is, it will be at least 3 means 3 accidents will occur. That is sure. And usually accidents occur either 3 or more. 3 or more means it can be 3 or it can be 4, it can be 5, it can be 6, 7, 8, 9, 10. So that is the concept. So out of 10, in the question it is mentioned that 10 accidents occur. What is the probability that at least 3 means probability or the basis of Poisson distribution, you have to find the probability with regard to 3. More than 3, at least 3 means all 3 accidents will occur. Even more than 3 will occur. That is 3, 4, 5, 6, 7, 8, 9, 10. So you have to find in case of all these individual items 3, 4, 5, 6, 7, 8, 9, 10. It's very difficult for finding the Poisson distribution in case of all these, but there is an easy method for that. Probability with regard to x greater than or equal to 3, that was the question mentioned here, 3, at least 3. Instead of that, why can't we use 1 minus probability of 0, 1, 2? Remember, at least 3 means 3 and above. So what is the remaining under the study, not under the consideration, is 0, 1 and 2. We are not studying about whether there is none events occur, 1 event occur, 2 event occur. We are studying only 3 and above. It is applicable only in case of total number of events 10 is mentioned. In such situations only we can do that. So instead of finding for 3, 4, 5, 6, 7, 8, 9, 10 and add together all these values, why can't we use or find the values of 0, 1 and 2, and if you deduct that value from 1, you will get the opposite of that. For example, you are given out of 10, 3 and above will have to be there. So that is 7. We can easily find that. Instead of that, we can deduct the 3 from 10. You will get the value 7. Likewise, instead of finding the probability of all those items, just find the value of 0, 1 and 2 and deduct it from 1. Just like the method which we have learned in case of probability for finding none events like that. At least one event means 1 minus none. We have learned that. It's almost similar to that pattern. So 1 minus e raised to minus 0.1. This is just the method which we have followed just previously. This is one will be constant, so we are using as a common factor, into m raised to x by x factorial for 0, same for 1 and same for 2. From this onwards, it is almost similar to the steps which we have followed. So 1 minus, here it is 1 minus e raised to minus 0.1, the value of minus 0.1 is 0.9048 into m raised to x is m, we already found 0.1 raised to x is, first case is 0, so let it be 0 divided by 0 factorial for first part, for 0. You need not have to use for 0, for understanding only for 0 is written, plus m raised to x is 0.1 raised to, next one is 1 divided by x factorial is 1 factorial, that is for the value 1. If it is for 2, it will be 0.1 raised to 2 divided by 2 factorial. So by solving that, you will get 1 minus 0.9048 into 1 plus 0.1 plus 0.005. You will get 1 minus 0.998 and finally you will get 0.0002. You would have get the same value if you find the probabilities of 3, 4, 5, 6, 7, 8, 9, 10, and if you add together all these, you will get the same value. Instead of that, you can use this method. And remember, it is applicable only when this kinds of values is given. Out of 10 it is mentioned. If it is not mentioned like that, it will be difficult. But it will be mentioned in the question. So remember, this type of methods also there for dealing with Poisson distribution cases. I hope you have understand the concept. Familiarize each of these cases. Remember the methods and steps which we have followed. Let us go to the next one. Another case. A car hire firm has 2 cars which it hires out day by day. The number of demands for car on each day is distributed as a Poisson variate with the mean 1.5. It is mean value already given. In the case mean value is already given, there will be issues or adjustments with regard to the question. Calculate the proportion of days on which neither car is used. First question. Second one, some demand is refused. So before we go into the computation part, understand, read the question very thoroughly, understand the concept, what is specified in the question, understand it. A car hire firm, it will be a taxi concern or a taxi company. They have only 2 cars. They hire the 2 cars for day-to-day activities or day by day. The number of demands for car on each day is distributed as Poisson variate with the mean 1.5. From the mean, the sentence itself, we can understand that it is a Poisson distribution situation. Calculate the proportion of days on which neither car is used. Neither car is used. How many cars are there? There are 2 cars. Neither car is used means none of it is used. So what is the value of x? Whether it is 2 or 0. Neither car is used. No car is used. That is the meaning. So the value of x will be 0. We all know how to find the Poisson distribution if the value of x is 0, and we already know the value of m. So we have dealt first one. Second part. Some demand is refused. Some demand is refused. The meaning of the sentence is the taxi concern has 2 cars, and one day a customer came to the shop and the customer asked for the car for any purpose, for hire, but the concern or the taxi company said that, sorry customer, we are unable to help right now. Such a sentence will be said to the customer, or a customer is turned back. Only 2 situations. Either the concern doesn't have any car, or the concern is closed down. In the question there is no mentioning about close down or closing of the concern. So a customer is turned back or a customer is sent away is because when the goods or the requirement of the customer is not there in the concern. So when demand is refused means some customers came for the car but they were turned back or they were sent away. That situation comes when the cars in the taxi concern or taxi whatever it is, they are hired for some other purpose. There is no car in the concern. That is the meaning of the sentence. So we will come to that part. During that computation part we will mention that. Right now just mention the meaning of the terms. So first of all, write down the details given in the question. It is in the question it is mentioned that the value of mean is 1.5. Neither car is used. That was the first question. If there is no demand for any car, no customer is there for the car, that is known as neither car is. That is a situation where car is not used. Hence the required proportion of the days on which no car is used is 0. So the value of Px is 0. So the computation is P of x equal to 0. And the value of e raised to minus 1.5 is 0.2231. If you refer the table, you get the value. And remember, when the x value is 0, the answer will be the table value of e raised to minus 1.5. So you need not have to do further calculation. The probability of neither car is used if you are using a Poisson distribution case is 0.2231. That is the answer. Next one, second part. Some demand is refused. Since the firm has only 2 cars, some demand will be refused. Some demand refused means some customer came for the car. The firm said that, sorry, we are helpless, we don't have any car right now. If the number of demands per day is greater than 2, the reason is that they doesn't have the car means the car is already hired by some other customers. So the demand for the car at that time will be more than 2, because more than 2 customers might have, or 2 customers, or when more than 2 customers comes only the demand is refusing or demand occurs. So the demand of the car in the second case is more than 2. Then only refusal of demand occurs. So the P of value will be, the value of x will be greater than 2. So greater than 2 means that is also another situation, an issue with regard to that. Just like the method which we have learned previously. Greater than 2 means it may be 2. It may be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, just going on like that. It may be 100 or 200 or 1000. How you are going to find the probability of 1000 customers? If there are 1000 customers came to that day, how we are going to find that? Even though there are only 2 cars and 2 cars is already taken by the 2 customers, If there are 1,000 customers came, you have to find the probability with regard to that. So how you are going to find? It's not easy. In this situation also, we have used the same example which we done previously. So instead of finding x equal greater than 2, why can't we find the value 1 minus p less than or equal to 2? That will be the opposite of x greater than 2. So this is how you have to deal with the situations where when a probability with regard to a value is greater than certain values or more number of probability distribution has to be learned, just do the opposite. Whichever is smaller, you choose wisely. So p greater than or equal to, sorry, p less than or equal to 2 means it will be 0, 1 and 2. And I hope you know how to find the probability with regard to the Poisson distribution. We have done the same steps and computations in the previous cases, and the same is repeating again and again. Until here you have to learn how to come to this area. From here on we have done the same step again and again, just like 1 minus e raised to minus 1.5 already given in the question, raised to 1.5 raised to 0 divided by 0 factorial. In case of 0, if it is 1, you need not have to put for 1 again. For 1 it is 0.5 raised to 1 divided by 1 factorial, and 2 it will be 0.15 raised to 2 divided by 2 factorial. So if you solve using the Poisson distribution situation, it will be 1 minus 0.2331, that is the table value of e raised to minus 1.5, and this value into this one, here it will be 1. So this value into this one, we have got this one. If you solve this one, that is 1.5 raised to 1 into 1 factorial, and multiply it with 2.331, you will get 0.33465. Try to do it yourself. And here 1.5 raised to 2 divided by 2 factorial, you will get a value, and multiply that value with 0.2331, you will get 0.250987. So this is how you have to deal with. And once you found all these three values, add together and deduct it from 1, you will get 0.19126. So that is the probability of situation when demand is refused. It's another case earlier. If you go through the cases which we have learned, you can see that almost the computation is almost similar. The only thing is that before you come to the substitution of various data into the equation, you have to do some tricky steps or some identical or different steps for each of these cases. So go through the cases, familiarize the situations. In what situation we are using that method, or in what situation we are using another method, likewise. Familiarize each cases, understand the situations, and just go through it. We will discuss about further cases in the next session. Before we go into that, and another important property with regard to the Poisson distribution, remember it. It is an important note. During the computation cases, in another computation cases, where you need to find the frequency f. So you need to find frequency, just like the f which we have learned in case of binomial distribution. If you want to learn f, you need to multiply n. N, the same the n that we have learned in case of binomial distribution, n into probability. Then you will get the f. Another important note or a property with regard to Poisson distribution is mean value is represented by small m, and it can be found by using the equation n into p. We have learned the same equation in the binomial situation also. Next one, variance. In the initial phase of the Poisson distribution, I have mentioned in the case of a theoretical part that mean of the Poisson distribution and variance of the Poisson distribution is always equal. And remember, standard deviation will be root of m. If you think wisely, you can see that the variance and why variance and mean is equal. Standard deviation is root of m. So how you are going to find the variance? If you remove the root, or if you take the square of m, you will get root m, the square, you will get the value of variance. So if you remove the root, it will become variance. If we remove the root, it will be m. M means mean. So automatically variance and m will become equal. That is the concept. You need not have to think about that in detail. Understand the properties, because during the computation of mean problem you will be needing and remember these methods and steps. It's very important. We will be discussing about the cases with regard to these nodes in the coming sessions. Until then, go through these cases. We will discuss about another functions and cases with regard to Poisson distribution in the next session.